Hello and welcome to tribetopper.com.
And you're watching this video on graphs of motion. In our previous videos, we defined and discussed distance, displacement, speed, velocity, and acceleration. And all of these are the important parameters to describe the motion of any object. In this module, we are going to discuss the distance time and velocity time graphs for the uniform and non-uniform motion. And while drawing these graphs, please note that generally in these graphs, the quantity such as distance or velocity is the dependent variable, so it will be plotted on the y-axis, and time is the independent variable, so it will be plotted on the x-axis. So let's look at this graph, xt graph for uniform motion. Xt graph means the distance time graph for uniform motion. So as you can see here, we see that there is a distance of 10 meters covered in 1 second, then 20 after 2 seconds, then 30 after 3 seconds, and 40 after 4 seconds. And you will see when you plot a graph, you will find that here I've taken x-axis, time, and y-axis is the distance. So when you plot the points 10, 20, 30, 40 on the y-axis and 1, 2, 3, 4 on the x-axis. So you get, when you'll plot the points, you'll get a straight line which is inclined to time axis. And this straight line inclined to time axis clearly indicates a linear relationship between the distance and time. So linear relationship means that as the time is increasing, the distance is also going to increase, and the time is increasing by equal amounts, and so is the distance. It is also changing, or the position is also changing by equal amounts. So this is a uniform motion graph. Interestingly, this graph has one more significance, and let's see that. If we find the slope of this graph, so slope is calculated as the height upon base. So let's take these 2 points. So height is 20 and the base is 2, right? So height is 20 here and base is 2 seconds. Therefore, we say that slope of this graph, if I mark these as points O, A and B, then the slope of the graph is AB upon OB, and AB is the height, which is 20 meters, upon OB is the time, which is 2 seconds. So that cancels out to give me 10 meters per second. From the unit, you find out that the slope is giving us the velocity of this graph, of this motion. So if the distance time graph is plotted and it's a straight line inclined to time axis, then the slope of that graph gives you the velocity, which is a constant one. And how do we come to know it is constant? You can find the slope at this point. You can also find the slope regarding this point, in reference to this point also, if I take this point as C. So OC, and here is D, then the slope would be, for this curve, the slope would be CD upon OD. So CD is the height now, that is 30 meters, and base is 3 seconds. So again, you would get 10 meters per second. So you can find out the slope between any 2 points. You'll always get it as 10 meters per second. So this also tells you that the velocity is constant for this motion. Let's look at another graph where we see that from 0 to 5 seconds, this is a straight line going up, but after 5 seconds, it becomes a horizontal line, and this is a position time graph. So since it's a position time graph, the first half, that is 0 to 5 seconds, indicates a linear relationship. So this part, this region refers to constant velocity, as we just discussed in the previous graph. But what about this portion? Now this region, since the position is not changing, it's at 25 meters for the next 5 seconds. So this region is the stationary part of the motion. So if the line graph is horizontal, like we see here after 5 seconds, we find that the slope is 0, and that means the velocity of the object is 0. 0 velocity means the position of the object is not changing with time. Right, so slope is 0 here because the line is parallel to time axis. That means slope gives you the velocity, which we just said, and here the slope is 0. So slope 0 means velocity is 0, and so no change of position is happening here. So the distance time graph gives us quite an important information. Now if we plot the velocity time graph, here I've taken velocity time graph for the same data for which we just calculated the velocity to be 10, and since it was constant, so what kind of graph you're going to get? So here this way I have t in seconds, and this way I have velocity in meters per second. So for a point where my velocity is 10 meters per second, you check it at 1 second or 2 seconds or any time, the velocity is not changing. So here 10, 10 and 10, and it continues. So what you're going to get is a straight line parallel to time axis, right? Since the velocity remains constant over time, we get a straight line parallel to time axis. Now there will be one significance for this graph also. Now that is that if we find the area of this VT curve, so if you look at this curve, it's OABC. So this portion is a rectangle or a square. So the area of this curve will be equal to the area of the block or rectangle OABC. That is length into breadth, as we know the formula, and length here is 1 second, 10 meters into 1 second. So this gives us 10 meter per second into seconds. So that is 10 meters. So from the unit we come to know this is distance. Thus we can say that the area under the VT curve or the VT graph gives the distance covered by the object in that time. So you have to note down here one thing. Slope of xt graph, that gives you velocity, and the area under the velocity time graph, that gives you the distance traveled in the given time interval. So both the graphs are important and give information about each other. Now we move to uniformly accelerated motion. We know that in this uniformly accelerated motion, the distance covered is not equal in equal intervals of time. Like we have here, the graph, the table says that distance is 1 meter in 1 second, then it's 2 meters in 2 seconds, 4 meters in 3 seconds, and 16 meters in 4 seconds. So in every interval, there is a difference in the distance traveled. Right, so this is definitely not going to give you a straight line, but when you plot these points with time on x-axis in seconds and the distance on y-axis in meters, you are going to get a curve of this kind, because these points, they give us not a linear relationship but a kind of exponential relationship. This we can say that from the graph of the distance time graph for the non-uniform motion tells us that the object is moving with non-uniform velocity, because it's not going to be a straight line, so it's not going to give you a same slope. The curved line tells us that distance covered in each time interval is different, therefore it has to be a variable velocity, and hence it's a non-uniform motion. Now let's check out a velocity time graph for a non-uniform motion. For a non-uniform motion, it can be uniformly accelerated or non-uniformly accelerated. So first we take the case of uniformly accelerated motion. So we have a velocity of 4 meters per second in 1 second, then 8 meters per second after 2 seconds, then it's 12 meters per second after 3 seconds, and 16 after 4 seconds. So in every time interval of 1 second, the velocity is changing by equal amounts, that is 4, 4 and 4. So when you'll plot a graph for velocity versus time, you are going to get a straight line as we got here, which is inclined to time axis. So velocity is not constant, but velocity is increasing at a constant rate. So for all uniformly accelerated motion, the velocity time graph will be a straight line inclined to time axis. Now let's check what can we get from the slope of the velocity time graph. So I have marked the point A, B and O as the origin. So slope you're going to get is from the height AB upon the base OB. Therefore slope of this given VT graph is AB upon OB, height upon base, and that gives you AB is 8 meter per second upon time is 2 seconds. So you get 4 meter per second square, and again the unit clearly indicates that this is giving you an acceleration of 4 meter per second square, and you can find out for any of the regions the slope you will get will be 4 meter per second square. Therefore this is a uniformly accelerated motion, that is the velocity is changing but the acceleration is constant, and that is 4 meter per second square. Now we have seen that we get a straight line for a VT graph if it's a uniformly increasing or decreasing velocity. But what about a non-uniformly increasing or decreasing velocity? So here you can see this kind of a curve which is clearly telling us that the velocity is increasing but not at a constant rate. And here the velocity is decreasing but not at a constant rate. So this indicates a non-uniform motion. Had it been like this or straight down, then that would have been a uniformly accelerated or uniformly retarded motion. But this graph, these two graphs, they tell us that the velocity is increasing or decreasing at a variable rate. So this is non-uniformly accelerated motion. I hope by now you should be able to predict the motion and its parameters when you look at the graph. That is all for now. We shall continue with the equations of motion in our next video. If you find this video was helpful,
please follow us on Instagram, Facebook and Twitter at tribetopper.com.